Okay, so I want to take a look at under the evaluate. We have interference detection, clearance verification. Haven't used the whole alignment, and I'm not entirely sure which. I know that these two are in 2016. I don't know about the whole alignment. Um, we've done quite a bit with the measure and the mass properties. Pretty much, you get over to the utilities. I guess the other one that I don't really have anything set up, but if you get different versions from a client, customer, manufacturing side, and go to compare, those fall under basic utilities that you can look at geometry, you can look at drawing, changes from drawing to drawing. So basic comparisons, and then we get into the express, simulation, flow, DriveWorks, the costing, and the sustainability. And again, these are the last three are really kind of out of the realm. We talked to really the scope of this class. What was the other one under the tools? The check drawings when we were looking at the drawings. Most all of these require that you invest some time up front to make that work. So I want to stay in my static configuration. Pretty much not going too crazy into some of those other things. I didn't get the handles in. So one of the this might be a good time to set a display state. I can create a new display state, and typically would rename that. I want one without any hardware, so this is going to make it a little easier to look at the interferences, because pretty much all of the screws and everything, they're in interference. They have to be, or they're connected at that point. So when we go back to the hardware folder, one of the nice things about managing those folders is that we can hide everything as a group. So why would I set a display state as opposed to the hardware? There may be other things in here that I want to end up hiding. So that being the case, the plugs, the clamp plugs, those are good candidates to hide as well. All right, so under the display state, going that route, I can show hardware. It comes back. I don't have to worry about things that I might have missed or embedded in the part. And it's that quick visual transition from hide to show. If I was managing it out of the configuration, instead of thinking about hide, show, transparency, solid, wireframe, those types of things, managing it out of the configuration, is it suppressed? Is it unsuppressed or suppressed? And does it participate in this whole what are the mass properties? Okay, so at this point, let's see, no materials have been specified. So that means everything, I believe, is 1 gram per cubic centimeter, basically water. All right, is our baseline number. For what we're doing tonight, we don't need those, but a quick way, just as illustration, since I haven't set these, if I've gone through and I've been focused on the assembly and getting all of this working, this is one of those places where pretty quickly out of the assembly I can go through and we're going to do plain carbon steel for the base and or the saddle, and then the center compound member went over to something else. No, I don't want to make it out of 304. Let's edit the material, and we'll go find a 1020 steel. I mentioned before in various times, be careful of the SS. The SS stands for stress strain, and that is a specific form of material. It has whatever conditions, and I have gotten calls because I haven't paid attention to that designation, and people, machine shop managers, quoters will say, do you really need stress strain? And I'm going, what's stress strain? Well, it says SS on the end of it. It's been through a secondary annealing process or secondary process to manage that material. All right, so 1020 We'll just apply a couple of these. So it does go pretty quick to edit the material. And out of this group, I'm not generating a lot of copper. So that might be one of the things that, let's go over to my favorites, and I really don't need copper, but I am putting enough 1020 in there that I want to add it back. And it would be nice that I'm adding enough that it's close to the top. Primarily 6061, secondary 304, and then we'll go to 1020. All right, so now I can click on it and just go 1020 next. All right, and go down through that list. So really the materials, that edit material and favorites list for your materials, that's kind of what you're using the most of, what you're kind of at the time. All right, so materials don't really play that much of a part in what we're shooting for here. So let's look at the interference detection. And interferences are from assemblies. So under the evaluate of a part, well, we're not really looking for an interference inside of a part. So we do need something that we can have those mates established and look at where those interferences are coming into play. All right, before I calculate, at the component view, options, treat coincidence as an interference. Well, technically, being concentric here and concentric here, they're touching. Is a zero an interference. The screws, this face and this face are touching. Is that an interference? Right. So how do we coincidence concentricities, and do we want to see those? Show ignored interferences. Okay, so if we set this one, then we probably want to not set that one. Subassemblies as an individual component. So mentioned previously that maybe this group could be a subassembly. Yeah, we may still try that, as depends on how much time. Multi-body part interferences. So we'll go back and look at the multi-body parts. So that master model situation where it's has the buildup, and create fastener folder, matching cosmetic threads folder, ignore hidden bodies and components. So I can turn off my all of the screws and the handles and everything that I set. All right, so I want to take a quick look through those. So the excluded components. Let's see if we have the list. Oh, I haven't calculated anything else, but basically would expect to see all the hardware listed in there. All right, so let's go ahead and run the calculation. No interferences. So what that means is that on the tolerances, when I went through and did the buildup, then there is that 2 or 3 thousandths gap, the 2 or 3 thousandths gap. Where there are coincidences, there are correct coincidences. Treat coincident as an interference. Now let's calculate it. Interference, 0.022 square inches, or cubic inches. All right, so the tool holder back to the set screw. Well, that makes sense because the set screw is oversized and is inside of, basically has to have an interference for the threads to work. This is not a threaded hole. The screw is, well, I don't think the set screw is threaded. They have the simplified thread forms. So there is an overlap of volume there to for it to work, for it to calculate. Let's see if we can find some other ones where the that plug clamp comes in, and it's looking at it as a coincident and interference. All right, so none of these are really surprises. What I would want to see is, regardless of the hardware, one of the reasons I hit it, told it to remove it, was none of that is really a great big surprise. What I'm looking for is a gross interference that, whoops, I missed a mate, and this thing is 1/8 of an inch into this part. I missed a dimension, and there is enough of an overlap that there is a serious gross error. And so, if we can catch those. But if I've gone through the process, if I've, even if I've done the basics of let's go into cross-section, and what am I seeing in cross-section? And go to the different cross-section views. Top isn't going to help me here. So go through those different cross-sections. Same thing, I should be able to see gross overlaps of material in those interferences. All right, so clearance verification along the same lines. Selected components, so let's go between those two. Between the selected items, I'll go ahead and calculate. Clearance of 14 thousandths. That was our plus or minus 7, plus or minus 7. All right, so we had I think a limit dimension that basically spanned that 14 thousandths. If this grew to its maximum, then we would have a little bit of an issue. All right, if we were at the upper limit of this part, then it would basically be touching both of the end plates, and I would have some drag there. It may not be to where it wouldn't move at all, but in my tolerancing, what do I really want to do with that gap? All right, so we're getting the same types of things, uninvolved options. We can go through and set for those that verification. All right, so just some real quick tools to check out. Hole alignments. Like I said, I'm not sure if this is a 2017, maybe in 2016. Hole center deviations. They give me a tooltip, that would be nice. No. Well, I wouldn't expect my deviation to be too far out, so let's go 10 thousandths. Maximum deviation of a thou. So the 1/8 inch. All right, so whatever that buildup, whatever was going on in that mate, is that within my positional tolerance for that location for those holes. That it gives me an option to say that if this is a 124 press, maybe this needs to be a 126 so that it can float between two holes. All right, if I hit those numbers, otherwise we're back to the original notes of, well, I need to assemble this and then set the whole assembly up in a mill and drill and ream this and press the pin in at the same time. That to me is kind of counter to the manufacturing process. I should be able to come up with a positional tolerance for the size of this hole, the size of the ream, press the pin in, slide this over the top of it, and positionally this will be within a thou. A couple thou at most. All right, so the deviation is showing me 1,000th of an inch. And really, except for rounding errors, it's probably smaller than that. So that could be something where I have the 124 or the 125, or when I set for the dimension, we had one of those 9/32 dimension as an odd example, but it was out at 0.28125. We made it out to the 5th decimal place. That's still enough for it to pick up as there's a deviation. If I didn't go to that level of decimal place in both of those parts as far as its position, as far as being mirrored across the center line or anything else, it's going to pick it up. So are these numbers realistic, and will I still be able to manage those positions? All right, so same thing on the various parts. It's all revolving around the tight tolerances around those 1/8 inch holes. So that's something that having that come up in the hole alignment, that's something I'd go back and take a second look at and do a reality check. Am I confident that I can press that pin in, and once it's pressed, those parts are pretty much together forever? Take a hammer to get them apart. All right, so the one that I still have not entirely, well, actually, there's a lot of things I haven't figured out, but in the way of the dimensional tolerances, let's go back to the base. We didn't quite finish out with the GD&T. We put some of the surface finish symbols. I was reading up on it, and then as soon as you start reading one thing and it kind of takes you through all of those different pathways, it becomes kind of a maze. Surface finish and stack ups of those tolerances, grind machining, and going to the grind. It's as complicated as you want to make it. All right, we want to keep it simple. I have 10 thousandths material here, 10 thousandths material here. When it goes through whatever machining process, and then when we hold the tolerance here, we ended up, I guess it was on that one. Yep, thought I said it. It should have that same tolerance on the width. And the plan is to not grind this face because I think from a machining standpoint for that retainer, I'm going to be okay with the pin locations, that this can be a machined in-mill surface and satisfy the requirements. This surface I want flat. So when we come back to the drawing and do the GD&T portion, I want that to be flat. All right, so and then the cylindricity of our arc. All right, so that's on the GD&T side. The one that we run into kind of often is this is our list of DIM Expert items. DIM Expert is a way of applying the dimensions, and we have a whole section in the options under the document properties. Yes, no, DIM Expert. All right, and if you're going to use DIM Expert, then recommend you take a look at the dimensions, plus or minus 5. I believe I have changed all of these from plus or minus 20, half a millimeter, 10 thousandths, somewhere in there, and updated for each of these items. All right, so as these get selected, these are the dimensions that are going to be applied as tolerances. All right, so one of the things that happens if you go into a smart dimension and you are not inside of a sketch, it takes you to DIM Expert location, and there are a few things that got added here from 2016. I believe the basic size and basic location. It used to be location, size, and reference. So now I have something else that I need to read up on. But the basic should give us this overall that we really didn't have before. All right, so a basic size is it's theoretically perfect. All right, no, without any tolerances being applied, the feature control frame is going to determine what those what the application of that tolerance is. So let's go with the size dimension, since you'll probably see it in 2016. And it comes up and says we're creating a width feature between two planes, so face 1 and face 2. And then when I go ahead and select it, it's showing me that there is a dimension 3.50. I have the same ability, plus 5 thousandths, symmetric, plus or minus 5 thousandths. And so we have a rounding, the rounding issue going on. So that would be something I'd go back into the options and see if I can update for those items. So 3-place dimension with a 3-place tolerance. All right, so I could go through and on each of these, let's see, so coming back over to the DIM Expert tab, DIM Expert Manager, we have the annotations, we have the width. And let's apply one more. I don't want to go too great. So on the tail end of this, I could dimension everything out of DIM Expert. There's a few things that I haven't quite got it haven't quite got it to that point to where it will dimension everything the way that I want it, but I can get a majority of dimensions in this 3D model, and we're almost to that point of model-based definitions. All right, so on model-based definitions, it takes this information and kind of takes it to the next level, that we're not going to create a drawing. This is the drawing. This is our working document. All right, so it's still, we've been talking for 20 years about paperless manufacturing. And it's moving that direction, but we're still not there. All right, so little by little. All right, so the DIM Expert item, location dimension. Now let's see if it'll do another size dimension, if it'll give me the cylindrical. And so the 2 inches plus or minus, same thing. Well, anytime I'm changing these more than once, I'm going to the options to look for where that's coming up. All right, so there was another, no, there was a height tolerance on that one. So, all right, so I'm going to save that. And under the annotations, when we right click, there are the show dim expert annotations. So I want to see them, I don't want to see them. And I believe as far as a display state, I can show and hide annotations as a part of my display state. At least some of them anyway. The reference dimensions definitely. All right, so what this is going to do is the more geometry that I assign these dim expert items to, then when I take this over to the tolerance analysis at the higher level, it's going to generate a report. So we have to build in this front side dimensioning to get that far. All right, so I'm going to pick the same two faces. So smart dimension, size, go into the face, finds face 1, face 2, go ahead and accept it, find some place to put it. And I'm pretty confident that that is in position, but I do want to check under the options, not customize, options, document properties, dim expert. So block tolerances, general tolerances, tolerance class medium, fine or coarse. All right, so we were doing size dimensions. I guess that means we're going to have to try fine. And what are the display options? Locations, no. No. Okay. Still didn't update that one, so if I need to update it, we'll select 3 decimals and 3 decimals. All right, so it went 3.525 plus or minus 5. So what I would normally do, now let's go ahead and finish this out, one more. What I would normally do is I would sit down, and while I was going through the drawing, the detailing side of things, I would look at this and go, my maximum material condition goes to 530. Minimum condition on the saddle goes to 530. Oh, well, they're capable of touching. Normal manufacturing is that, reasonably, hopefully, the chances of all of these parts ending up at 530, we may have a few of them, but we're not going to be in a position where they're all of them. So, and since I went to fine, there is the 3 decimal places, 3 decimal places. All right, so I need to save that one. All right, so under the add-ins, there is at the, I think it's still a premium level, but at the premium level, it's a tolerance analysis. And since I don't do this every day, it's probably been better than a year since the last time I set up for the tolerance analysis. Where does it put that now? Nope. And it didn't come up as a tab. I didn't throw it at the end. Uh-oh. Now it's going to be the fun one because I'm not sure where I'm supposed to look for it. Okay, now performance. Nope, that's okay. Let's pause. Okay, so the one that I always forget is to come up to the search. We'll type in tolerance analysis study. Select 2 dim expert features from and to define a measurement. So we should have the, yeah, it does. Now how do I get to the dim expert? Oh, no. Okay, so it went to the width. Oh, I bet I went the wrong way. Or I grabbed the wrong one. All right, so I was talking and not paying attention to what I was doing as usual. No, that would be, so it was across the face. Whoops. All right, so one more dimension, face to face, accept. All right, so it does require that dim expert item, and it is going to track it. All right, so tolerance, analysis study, measure from, across the face, measure to, and it's showing me a 0, 0 on the center. Min condition, max condition, well, other ways. And at one point, and the measurement direction in U, Z and in U, no X, Y's. So center distance went back to 0 and center distance. All right, so we can do the min-max conditions. Measurement is defined, select from the available options or click next. All right, so the base part, tolerance, and base part is the saddle. The neighbors are the center compound, and we didn't put any dim expert on the lowers. So that was the assembly sequence, and so that generates the study. Once you have the study, then that should generate the report. So I was thinking that it would give us the. Let's go ahead and rebuild. I was thinking that once we had that point, it would tell us that 14 thousandths gap that we saw in the clearance. I was looking for that stack up of min and max. All right, so let's see, tolerance now. Oh, okay. So at the end of the dim expert item there. Now I may need more information, but based on the tolerances from the dim expert, the next step is to well, last time I did this anyway, the next step was to generate the report that would say, if this went to its maximum material condition, this went to its minimum, what is your remaining clearance? Or what are the values? If this went to its minimum material condition, and this went to its maximum material condition, what is now the gap tolerance? I'll say how much, and so going through all of the components in the system, end up with a report that says for these components between each other, what is the worst case scenarios? What is the maximum gap that you would end up? What is the minimum gap that you would work from? All right, so that's changed enough that I have some homework to do. All right, so that gives you kind of an idea. One of the things from the manufacturing going into the machining, sometimes when I just need some quick reference dimensions, dim expert will jump in and I don't have to create a full drawing. I have enough information on the screen and from the programming of the part, but it's nice to have that dimension for reference, and the dim expert dimension is a really quick way of popping it up. All right, so let's save that one. The one that I didn't try, and we'll see if we can apply it, because I saw it in the model items. And what I'm not sure about is, nope. Let's see. It's still out of the assembly, so let's go back into one of the parts. Nope, didn't want to edit that one. Yep, nope, not editing the feature. All right, so the other items here were the basic location, basic size, tolerance status. All right, so paint the faces of the tolerance features. So if you're looking for things that may be left. Anytime I see auto, I'm always a little hesitant to jump directly into an auto dimension, auto anything. But let's go ahead and give it a shot. Prismatic, part type. So it's looking for the geometries, or turned, is it cylindrical? And the tolerance type, plus or minus, well, that's what we pretty much applied here, is plus or minus. So we switch over to geometric. Then pattern dimension will be linear. And we need a primary datum, so typically the bottom face. Yeah, that's a single. The secondary datum, well, needs something I can actually measure from, so the end. And the tertiary, front face. All features are selected features, and then all of the feature filters. Since I switched this over to the geometric dimension tolerancing, I'm expecting as it goes through and calculates that I will end up with a bunch of feature control frames. So my hesitation about anything automatic is I don't really need a lot of these, and I didn't go through the filtering process or the selection process to say, hey, just this geometry. And even within this process, I'm going to have to go back through and take a look at the positional for the feature control frames, for perpendicularity, flatness, parallelisms, anything that comes up in the mix. All right, so we end up with quite the interesting. Yeah, we end up with a little bit of a mess here. All right, but there is enough information in there to get it started. So what I want to look at, my intent. Now, what I didn't find, basic location, basic dimensions, is I wanted to, under the dimensions, no. Geometry analysis, no. I'm thinking there's a way to apply those. I've always applied the GD&T symbols out of the drawing, basically bypassing the part. So going through the DIM expert, we get a lot of those, but I need to be able to apply those individually, and that's something I have to look for as well. All right, so we come back to our drawing. Oh, that was the assembly drawing. So no, we don't need to save that. Let's go. There we go, to the parts file. Okay. And want to select on that face. Let's look at the model items. There we go, model items. We already brought in the base dimensions, hole callouts. And so under the annotations, there is the geometric tolerances. Let's go ahead and bring in the datums. I don't have any datum targets that I know about. I guess I'm locked into, yeah, we'll eliminate duplicates, and then we'll keep our fingers crossed. No model item was inserted. Import from to entire model, so I missed something here. All right, so let's go that route. It brought in the one dimension that I pulled out because of the machining. So it doesn't quite look like it did what I expected it to. That never happens. All right, so selected feature, entire model, GD&T, one more pass at it, no dimensions. All right. All of that GD&T on the DIM experts, and it didn't find it. So that may be because it was DIM expert. Some of the things that show up as far as the model dimensions, let's find a basic dimension here somewhere that we can pull from, is where reference dimensions are called RD. Under the primary value, this is a TXD22 scheme 2. All right, whatever that means. All right, so it doesn't have the same level as if we applied a reference dimension and it got an RD1 value, or was a D1, D2 at sketch, at a feature, at assembly, at whatever. All right, as it goes through the hierarchy. So it may not be pulling those because it can't. So that being the case, so if we go back to just the geometric tolerance, I would be interested to see, I want a flatness, see if it'll let me rotate that over, of, well, let's go 2,000, so it's not crazy, but has a little bit to it. And planar face and position. And over constrained, that's nice, but I'm okay with that. So where exactly is that one in the list? Distance between. All right, so what did that one get called? That's a GTOL. So one of the things with the piggyback installation is the global tolerances may be pointed back to a previous version, and that's where we had to go back into the options and identify that location. All right, so if some of these are giving you a warning, that would be a start to check. All right, so one more thing, which configuration was I in? Default and plane 1. Ah, there's the flatness right there. So question is, will it bring in mine when it ignored that one? So one more time with the model items before I give up. Entire model, drawing view, datums, and feature control frames. Still no dimensions. All right. I can live with that, I suppose. So something else I get to look into, why it didn't bring those in. All right, so 500 plus for the bilateral, upper lower limits. I'm going to take that one back out. All right, so we go into the datum feature, and this is going to now start us on applying those tolerances. So I pick the line, datum reference updates, and we have our locations. And again, not particularly following any standard, just kind of getting it in there. So datum, we go to the geometric tolerance, same window we saw out of the part. Flatness, I want 0.002. And let's see, which one does that get applied to? We go directly to the face. Okay. So once the control frame is selected, then we can tell it no leader. And to a certain extent, apply it to the datum. All right. Now the issue with doing that is, does everything move together? Was it applied correctly to that view? If it's outside of the view, then that will stay stationary. All right. There's also a little bit of mismatch in the lines, getting everything kind of snapped together. What else do we want to put in? Some cylindricity. All right, so circularity, cylindricity. We had a plus minus dimension on the height, but it wasn't really called out as how cylindrical it needed to be. So let's say it's within 4 thousandths. All right, so what does that work out to? The 0.01 millimeters or 0.1 millimeters. And in relation to, it's just cylindricity. It doesn't pick up. So positional for the center line, I think that would be the reference. Oh, and I applied it, and then I didn't attach it to anything. So let's get the leader going. Try not to make too big of a mess here. And then just a quick double check that it's moving correctly. And we'll go through and apply those frames. We had some positional tolerances in there, and so we'll just do a couple of these so that we can go back to. So I don't have anything related back to the hole location. And don't really have anything that really needs parallel of a thou. But we will apply one anyway. Hit OK. When we look at the locations, multi-jog all around the different styles. Let's say one of those versus the direction. Oh, there we go. And then the primary frame was to datum A. So we could do datum A perpendicular to datum C, and do the stack up. All right. So stack up looks like perpendicular within 2 thou to datum B. All right, we start building up those frames. All right, so once again, when I think of GD&T, it's supposed to make things easier, make things less complicated, and what ends up happening is if it's not applied correctly, it creates more confusion and leaves things open to interpretation. So try to pick your datums. How's it go? Pick your datums from things that are measurable, that you're establishing as in the first few operations of creating the part. And then as you're building out through the frames, don't overdo it. You know, pick out the geometry that is critical and apply the feature control frames, apply your basic dimensions, and that is one that I did not put in there. So this one, as far as its position, this should be a basic dimension, and then somewhere a feature control frame related back to A for the position of the bottom of that cylinder. All right, so start thinking. It's very easy to overthink, and you want to put more. Less is more. I don't know how else to put it. Is try not to overcomplicate it to where you're having to follow through all of these datums, all of these feature control frames to get to what it is you really want, which is just the part. All right, so we have some tools. Again, if we're using them every day and they become part of your workflow, they become much more seamless than I'm making some of these look. And you can certainly build a lot more information into your models if you are working in that critical tolerance zone. We talked a little bit last time that our standard tolerances were pretty much what we had put over in the title block. Plus or minus 15 thousandths. Some places maybe plus or minus 30 thousandths. Some places, if we're in the woods and construction, plus or minus 60, plus or minus 1/8 of an inch. All right. Now, cut it and hammer to fit. Type tolerances. The commonly accepted machine shop, plus or minus 5 thousandths is a general tolerance. All right, that is still a pretty big hole to fall into. I mentioned that under 4-place decimals is what is it you're really trying to control. Do you want a secondary operation? So 4-place decimal, a plus or minus a thou, with a little bit of caution, I can still get that with a mill. I can still get that with a standard lathe. A reasonably tight machine will produce that tolerance with a little bit of effort. It'll produce the decent surface finishes. So, on that end, do I need more than plus or minus a thou? Well, if I do, and I'm doing it consistently, then I would want to apply it here. Plus or minus half a thou would take me to another level. Plus or minus 0.2 of a thousand is kind of the commonly accepted what you would see on aerospace drawings in a lot of instances. 0.2 of a thousand says I'm no longer in the mill, something that I can inspect and machine with an end mill, with a drill, with standard, maybe even standard reamers. We have to go over to grinding. We have to go over to, in certain cases, EDM will be able to satisfy the conditions. Wire EDM. Or we may have to go to jig board, jig grinding to get to that level of tolerance. So how much cost do you want to inject into your part? That 4th decimal place with a 0 out here, in a lot of cases, just up the price of this part 10, 20%. And I go out another decimal place, you may have doubled it, you may have tripled it. All right, so one of the things I say with quite often with the tolerances is if you default to 4 decimal places, this is a legal document. This is a contract. I'm accepting the work on this document, and if there are 4 places here, you can come back and hold me to it. So I make the point, and it's kind of a mean point, but people that send me 4 decimal place tolerance drawings, they get a quote that is, I'm going to hold 4 decimal places to your tolerance on all of these dimensions. And they go, $100 a piece. Why? Because you put 4 decimal places everywhere and you can legally hold me to it. If I make you a 1,000-piece order and they fall outside of that tolerance zone, you can reject them and you cannot pay me. Or you can get to that point of you don't feel you have to pay me. You don't have to pay for the parts. All right. So on that delivery portion of it is, on plus or minus 2 decimal places, like I mentioned, I'm probably going to go to the nominal dimension of a 2 decimal place because the stack-ups are kind of a pain to work with. We get, from a machinist standpoint, I think in terms of 3 decimal places. So when I see a 2 decimal place dimension or a 1 decimal place dimension, I'm still carrying it out 3 decimal places. It just works better to stay in that mindset, stay in that consistency. So understanding on the design side, I don't necessarily need 3 decimal places, but understand what happens when you put 2 or 1 or none. And definitely understand what happens when you put 4 or 5 when you don't need it. Okay, so we'll work a little bit. I think I'll try to build out some more of the dimensions on this. For these parts and what this is doing, anything that is a jig or fixture. So jig holds the tool, fixture holds the part as a general reference. Anything that becomes a jig or a fixture typically needs an order of magnitude above what you would do for the normal tolerances of the part. You want a tighter fixture tolerance that, so that as it wears, as it gets used, your parts the tools that you're actually making are going to stay within tolerance. They're going to stay consistent. Right? So we need to decide where those tolerances are going to land. And going through this, I don't want to inject any more tolerancing in this than I need. Standard tolerances for CNC, standard tolerance even for the manual milling and the grinding of the surfaces are going to, in most cases, be well within the tolerances that we need for this part, even at that order of magnitude above. So in this case, we would say that if our standard tolerances for the tool or the part are 5 thousandths, the tolerances for this fixture need to be half a thou. That's a little extreme. It's not outside of the acceptable range, But we need to make that conscious decision, not just go into it haphazardly. Well, industry says that this all needs to be plus or minus half a thou. Like we just said earlier, we've doubled or tripled the cost of this part for a slot that in no way, shape, or form 0.56 needs to be 0.5600. All right? The critical dimensions in these areas, yes. Everything else, not so much. All right, so take into consideration what the function of that geometry is doing before we go in and start applying a lot of GD&T and start applying a lot of those four decimal place dimensions. It comes back to use some common sense. All right, if I'm manufacturing this, if I was building this, what would I reasonably be able to hold as far as a tolerance, and then what is the special case that, yes, I'm going to have to take it to grinding, yes, I'm going to have to take it to EDM, I have to take it to another process to get to that tolerance and ensure that I have that precision. Okay.